Hello, today I'm going to be talking about POSIX signals, what they are, and then I have a tutorial which will help us understand how signals work in operating systems. Firstly, POSIX stands for Portable Operating System Interface Signals, and these are basically used to notify functions or processes about the occurrence of an event, or they may be used to facilitate communication between different processes. Now, the communication aspect we can look into more later on when we understand the functionality of fork and how parallel processes work. For now, signals are basically asynchronous notifications that are used to trigger some kind of action. Now, these actions are either defined already in the operating system, or they can be defined by the user, and then once that signal is invoked, the process will act the way the user defined it to act. Um, Now, I want to talk about two kinds of notifications that are currently there. Firstly, interrupts. Interrupts are generated by hardware, and what happens when an interrupt is generated by hardware is whatever process is currently in the kernel is saved and is saved at the current state, and then whatever interrupt occurred is linked to an ISR, which is an interrupt service routine, which are actions that take to handle that interrupt. Now, once the ISR is completed, what happens is the kernel takes the process that was previously occurring and that's loaded back into the kernel, and then it resumes processing the same way it was. Signals are the same except for they're generated by software. Now, let's go ahead and look into the code that I have written over here. Firstly, let's go ahead and look into this code, and this is a very simple code. It's just a while loop that's gonna keep printing operating systems are cool, because operating systems are cool. Let's go ahead and run this function, and it's gonna keep running until I press Control Z, which I'm not gonna do anything right now. Control Z, what it does is whatever process is currently in the kernel, it's gonna pause it. It's not gonna terminate it, it's gonna pause it. So let's go over here. I'm gonna press Control Z. Now you can see over here, this is basically the signal that says Control Z was pressed, and then this pauses that process. Now, if I press FG, it's gonna resume that process, and I'm gonna let's look over here. Now, when press Control Z, this terminates the process. Now let's go ahead and terminate this process because we're not going to be looking at it. Let's clear this, and now let's go ahead and look into the function that, or the code that's going to help us understand how signals work. Now let's go ahead and look into this code. I'm going to go line by line to explain how I've written this code out. The first thing that we can see over here is this function signal. Now, signal is a predefined function in the header file signal.h. Signal takes two parameters. First is an integer, which is this integer is related to over here. Each signal has a related integer in the signal.h header file. And then second is a function that is, actually C doesn't have functions. So handler is basically a pointer that points to a function, because we cannot pass functions as parameters in the language of C. The second line says print F, press Control Z to invoke custom handler. Now over here, it's just a print statement, and then the next is an infinite while loop, and I have a sleep function in there to save CPU resources, because usually if you have an infinite loop, it's gonna keep running over and over, and it's gonna make your CPU thermal throttle. So what happens is whenever you press Control Z, now previously we looked at it's gonna pause the function and then you can resume the function. However, this function signal is basically like a custom handler. So what happens is when this Control Z function is received by this process, instead of pausing it, it goes over here, and then which is our custom handler, and it's gonna go over here and say, did you press Control Z? And then it's gonna tell you a signal number. The signal number is basically a parameter of the signal which is received by the function of signal. Our signal number is either going to be 18, 20, or 24 because we can look at that's the value. Let's go ahead and run this function and make and one tip I would give to you as a programmer is usually try to handle your warnings, because usually when you have warnings it may be a hurdle and may stop your code to act the way that it's supposed to. And this is usually also helps you or benefits you when you learn more about warnings. It helps you understand that why the warning was being caused. I know why the warning is being caused, and I'm not going to change it now. Let's go ahead and run our program. And it says press Control Z, so I'm going to press Control Z. And you can see over here, this is what indicates the pressing of Control Z. I press Control Z, so instead of pausing that function, it goes to our custom handler and asks us, did you press Control Z? And then it gives us the signal number. So if you keep pressing it, it's going to keep doing that. At no point, because in our code, we have a custom handler for Control Z, it's not going to act the way it's supposed to because we user defined it. Now, if I press Control C, which we looked at, terminates the process, it's going to act the same way because we do not have a custom handler for Control C. So this is basically how you can use custom handlers to handle signals in C and operating system. Hopefully this video was helpful and will help you in your assignment. Thank you.